order to do the titration, we are going to measure about 0.2 gram of the solid acid, because based on solubility, now we know it's a carboxylic acid. So I just call it the acid. I place the Erlenmeyer flask, and I'm going to add enough of this unknown sample to the flask to make it 0.2 grams. So okay, that's a better. So I have 0.08. $189. So it doesn't have to be 0.000, but whatever number you have, as close as possible to 0.2, you need to record that number as 0.204 grams, and we take it to dissolve in ethanol. We're going to dissolve the sample because we know this sample does not dissolve in water. We already did the solubility test. 50 milliliter. Again, it's used to dissolve the sample. It doesn't have to be 50.00, or we cannot measure 2 decimal place anyway with the graduate cylinder. At least with the 50 ml graduate cylinder. It's going to dissolve, and we add the phenolphthalein, like 2-3 drops of the phenolphthalein. Going to let it stand and dissolve completely while I'm preparing the burette. To prepare the burette, I did wash with the deionized water already, but just for the video purpose, I am washing it again with the DI water. So that would be the first step. After we wash it with the deionized water, next step, I'm using standardized sodium hydroxide. Okay, sodium hydroxide is not a primary standard. So when it's prepared, it needs to be standardized. We are using standardized sodium hydroxide with 1 molar. I always tell the students, make sure you label the beakers when you are doing titration, and I only dispense the standardized sodium hydroxide into a labeled beaker. So if they come with no label beaker, they won't get any sodium hydroxide. Even the waste container, I label it, so I don't, and I try to use different size of the beakers. And I'm going to use about 5 to 10 milliliter of the sodium hydroxide to rinse the burette with the sodium hydroxide. This way, the sodium hydroxide is not going to be diluted by what the drops of water that is left in the burette, and it would help us to get better results of the titration. After I rinse it with the sodium hydroxide, I drain into the waste container that I had. Now, I'm going to fill up the burette, and it's always safer to use a small beaker funnel for that. I'm going to fill it up with the standard, which is the sodium hydroxide in this case. So the meniscus should be at the line. So this is going to be like a 10.00, and 10.00 is the initial feeding for the burette. And going to add sodium hydroxide until I see the color change. As I'm adding sodium hydroxide, I will mix the solution. And you might see that a pink color appears in the center and it disappears. Okay, we kind of modified the light slightly for you to see the pink color better. I hope you can see the pink color now. It appears in the center, and as I mix it, it disappears. I'm going to continue adding until the pink color is stays or is steady for 20 seconds, just like other rules for titration. So the pink color appears. As I mix it, it disappears. If the life of the pink color it's longer, that means it's much closer to the end point of reaction. So I'm just adding slowly and little by little. To the end point of reaction, you see the pink color disappears. You know, it takes longer for it to disappear. So at this point, I'm just adding one drop at the time, mix it, add another drop, and mix it. Okay. So with one drop, the pink color now it's the pink color appeared and it's staying so far. It's been stable for enough time to call this endpoint of the reaction. The volume used for this titration is about like 15, and to be exact, we start from 10.00 and it goes down to like 14.9. You do 2 trial of the experiment, you do the calculation separately because you might start with different mass. If the mass is exact the same, then you can take the average of the volume. But if the mass is different to initial mass that you're starting with, you have to do the calculation and then you find the molar mass. Then you take the average of the 2 molar mass that you found. To bring this one to 25 exactly, and we use the 25 milliliter to start this titration. So let's get the mass of the acid for second trial. As for the second trial, we are aiming again for 0.2 or as close as possible to the to 0.2. We tear this balance, place the Erlenmeyer flask, and press the tear so it doesn't read the mass of the flask. I don't have to do any calculation there. I'm adding enough to get to the 0.2 grams. And I do this like tap, just add smaller amount at the time. Okay. 50 milliliters, almost 50 milliliters of the ethanol, and 3 drops of the phenolphthalein. We're going to dissolve it. Record the initial reading of the burette for second trial, which is 25, just 25.00. I adjusted to 25.00. Start adding. The second trial, we can move faster. We already know that it's going to use about 14 milliliters. So I can go from 25 to 39 fast, and then start adding the slowly. Okay. Very close to it. And it's pink color. So we have the endpoint of the reaction, that's 39.7. We did 2 trials of the titration. One used 14.9, the other one used 14.7. The numbers are close to one another, so we don't have to do a third trial. So you're going to do the calculation separately and take the molar mass, the average of the 2 molar masses, and record that number as the molar mass of the unknown sample. And with the table that is provided or possible acids with given melting point, you are going to find the molar mass, the literature value for molar mass for different acids, and match the closest that you have the melting point for the compound and also the molar mass for the acid in order to find name for the unknown. And this is the identification for unknown A. You are going to write a report and identify your unknown A.